Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. In this video, I would like to present to all of you about my answer in the question 1, which is to find the least square solution to the system linear. In this video, I'm going to take a look of finding the least square solution to a system, which is AX equal to B. Suppose that A is equal to 269, 786, 453, 3x7, and B equal to 7, 6, 8, and 2. Since we want our system in the form of AX equal to B, we will write as follows. A times the 3 by 1 matrix consisting of x1, x2, and x3 equal to our B matrix. Next, we have step 2 and step 3. We can solve the system by taking the transpose of A and multiply it by A. So, in the other words, find A transpose times A and A transpose times B. A transpose is equal to 2743, 9858, 9637. Hence, A transpose times A is equal to 78, 112, 93, 112, 189, 173, 93, 173, and the last one, 175. Meanwhile, our A transpose times B is equal to 94, 146, and the last one, 137. Next, we have step 4. Hence, we know that AX is not equal to B and it has no solution, but we almost get it by the least square solution. And we can find a least square solution if we multiply both sides by A transpose. We know that A transpose times A times our least square solution is going to be equal to A transpose times B. So, to find the solution, we use reduced row echelon form, RREF method. Here are the following steps to get the RREF matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. And the last step is the answer of A. After all the RREF done, we can determine the least square solution for the value of x1, x2, and x3. I think that's all for me. Thank you.
Good day to Dr. Nurul Akmal and my fellow friends. So today I'm going to be presenting about orthogonal and also orthonormal. So first, we are going to look at how to use the Gram-Schmidt method to find the orthogonal basis of column space of matrix A. So as you all can see, we are given the span matrix, which is 2, 7, 4, 3, 6, 8, 5, 8, and 9, 6, 3, 7. So first, we are going to classify the given matrix into V1, V2, and V3 as follows. Then we are going to find U1. U1 is equal to V1, which is 2, 7, 4, 3. Next, we are going to find U2 as follows. As you all can see, there is a written formula. We have to use the formula to find our U2. And our U2 is 3.128205, negative 2.051282, negative 0.743590, and 3.692308. Now we are going to find our U3. The given formula is the way to find the U3. So after you insert all the given matrix into the formula, our answer will be U3 equivalent to 2.234759, 0.526387, negative 0.727934, and negative 1.747498. So these are the orthogonal bases for column space of matrix A. So now we are going to be using the Gram-Schmidt method to find the orthonormal basis of column space of matrix A. So first we are going to find the magnitude of U1, which is square root of 78. Magnitude of U2 is 5.308436. Magnitude of U3 is 2.975713. So now we are going to find the W1, so which is 0.226455, 0.792594, 0.452911, and 0.339683. Next, we are going to look at how to find the W2. So the value of W2 is 0.589289, negative 0.386419, negative 0.14007, and lastly 0.695555. And the value of W3 is 0.571000, 0.176,894, negative 0.244625, and negative 0.587254. So these are the orthonormal bases of column space of matrix A. Next, we are going to look at how to use the QR factorization. Now we are going to look at how to solve x using QR factorization. So the first step is you have to know the orthogonal basis of column space of matrix A, which we have already found just now as below. Next step is you have to find the orthonormal basis of column space of matrix A, which we have also found just now as below. So now we are going to find the matrix of Q. Matrix of Q is equivalent to the orthonormal basis of column space of matrix A. So then we will find the Q transpose. As you all can see, that is the matrix of Q transpose. Then we are going to find the R, which is equivalent to Q transpose multiplied by A. So that is the given matrix or the found matrix of matrix R. Now we are going to find the R inverse. R inverse is equivalent to 1 over magnitude of R. So first we would like to find the magnitude of R. So the magnitude of R is 139.509706. Then we will find the value of R inverse. As you all can see, I've already found the matrix of R inverse. So the next step is I will be finding the Q transpose multiplied by B. So the matrix of Q transpose multiplied by matrix B will be 10.643403, 2.077003, and 3.186328. And next, I'm going to be using the formula like I said just now, which is x equivalent to R inverse multiplied by Q transpose multiplied by matrix B. So my value for x is 1.520514, negative 1.108430, and the last answer is 1.070950. So that's all from me. Thank you.
Good day to our beloved lecturer and my fellow friends. Today I am going to present the question 1 regarding the least square solution using Mathematica software. So for that, first we have to insert the matrix A and matrix B given in the question, and then for this we have to address the matrix A as matrix M and matrix B remain as matrix B. So the command we use is least square bracket M comma B for this least square solution. So for that, finally the output we get is for x1, x2 and x3. For x1 we will get 1.51986. For the x2 we will get negative 1.10847, and for the x3 we will get 1.07096. So we move on to the question 2. Question 2 is regarding the orthogonal basis using Gram-Schmidt. For this, we have to use the Mathematica software. So now we have to insert again the matrix A, which is given in the question. So once again, we have to address the matrix A as matrix M, and then the command we used is transpose orthogonalize. Transpose, we have to insert the matrix M to get the output as the matrix form. So finally, we will get the four set of numbers as a output, which is 2, 6, 9, 7, 8, 6, 4, 5, 3, and 3, 8, 7. And finally, finally as the output for the orthonormal basis, we will get W1, W2, and W3. For W1, we will get 0.22647, 0.79259, 0.45291, and 0.339868. And for the W2, we will get 0.454099, negative 0.38642, negative 0.14008, and 0.69555. And finally, for the W3, we will get 0.75100, 0.17690, negative 0.24462, and 0.5872. That's all from me. Thank you.
Hello there, I'm Kishantini Loganathan and with the metric number of D2021095785, and I'm going to explain on how to solve X using the QR factorization. Okay, so let me show you the first coding. I'm going to show you the B metric to display and define this very process. And we would like to do the QR decomposition to find the R metric. So the command is QTR equals to QR decomposition of M metric. So M metric here in this coding is defined by the metric in the manual writing. Okay, so as you all can see, this is the output for the coding. And yeah, so as you can see, there are three rows here. Okay, so for the first line, we are going to show you the Q is the B metric, whereas for the first two line is the QT metric or Q transpose metric, and the last line is for the R metric. So this is the output for the previous coding. So as you all can see, this is the next coding. QT double slash metric form, R double slash metric form. Okay, so here I'm going to display the metric form in a QTR in a proper way. Hence the command for QT double slash metric form and R double slash metric form. Okay, so next is the x equals to inverse bracket r bracket dot qt dot b and map bracket matrix form comma bracket q comma r comma bracket and x equals to n bracket inverse bracket r bracket close bracket dot and qt dot b and a bracket. Okay, so this with this we are going to see the output as well. So as you can see, this is the output for the previous coding. As you can see, okay, so we are going to show you the x value here is 3. So here are the outputs. So here is the display of Q and R metric, and the last output is for the x value for QR factorization. Okay, so as you all can see, all of this is in a metric form, and the last output is for the x value. So there are 3 x values, as you can see below. Hence, we have found the x value for the QR factorizations, and we assume that our manual and also the coding is the coding average are the same. So thank you so much.